Hi, Mackenzie. I'm going to do my best to respond to your questions here. Some of them I'm going to do a better job at than others, I think, just based on the question. Some of it might just involve a conversation. First, I'm going to skip to your graphing questions because I think that those will be the easiest to solve here. So 3 and 4. So you said you're having trouble viewing the actual graph on the calculator. And without seeing your calculator, I don't know exactly what the problem is, but my guess, okay, so let's say that you put your data in. You had some points in here. Let's say it was your L1 and L2 here, and you just wanted to plot those points. So normally you would just go to graph, and let's say you're not seeing the points here. And I can think of 2 reasons that may be the case. So one of them, where the calculator says stat plot here, I want you to go to second stat plot, and this plot 1, right now mine says off, that needs to be on. So leave 1 highlighted, push enter, and switch that over to on. Okay, see how that's highlighted? Now go back to the graph. You may or may not see the points yet, but go back to the graph. Depending on what your data is, what the numbers are, you may or may not see the points at this point because your automatic viewing rectangle here is from -10 to 10 and -10 to 10 on the x-axis and the y-axis. So if your numbers are out of that range, you're not going to see them right here. So we need to make it so that it shows up on the screen based on the numbers that you're given. Different ways you can do this. One thing is you could go to the window, and this tells you your x-min, x-max that shows up on the screen, and the y-min and y-max, and you can change those numbers accordingly. So I don't remember what numbers I had in here, so let me go look here. We had from 12-ish to 13-ish. So I like to start at 0. So I might tell my x's to be from 0 to 15. And these are my y's. They seem to range from 9 something on up to 15 would cover it. So I'm going to tell the x's to go from 0 to 15 and the y's to go from 0 to 15 to show up that way. So my x-min is going to be 0 and my x-max is going to be 15. My y-min I'm going to change to 0 and my y-max is going to be 15. So it's just going to change the angle that you're going to see. So there's my data there. Okay, now I knew there was going to be a lot of dead space here. If you don't like that, you don't have to have your x's and y's start at 0, but just to give myself my origin, my base point of 0, 0, I just like to have it there if I could. Now if the numbers are huge, then I wouldn't do that, but that way I can see the data. And you can play around with this window however you want. Okay, so let me go back to your question here. So you said you're having trouble viewing the actual graph. So maybe that would solve that problem. But again, I'm not 100% sure what your problem is, but maybe that's it. So make sure you turn the stat plot on, and then you have to change your window. And then number 4, you say you couldn't get the formatting of the equations for linear regression to work. You understand what the equation needs to be, but you can't get it to accept it. So I'm not sure what you mean by formatting there. I'm not sure if you are saying that you're getting your equation, but you're not typing it into the online homework correctly. Let me just kind of go look here. All right, so this is your online homework. Let me go to that section. And I'm not thinking maybe that's 12.3. So this might be what you're talking about, that you have the equation, you think you have it right, but it's counting it wrong, which I agree with here. Any equation has to have an x and a y in it. So when you come up with the equation right now you're just putting in, this is the answer down here, you're putting in this part of it, which is correct. You have to have a y equals at the front. Okay, so just make sure you put that y equals in. I don't see answers the rest of the way, so maybe you stopped there because you were stuck. But it does look like you're doing that correctly, but just make sure it's y equals and then the rest of the numbers in x like you have here. Okay, so hopefully that answers 3 and 4. Number 2, you said solving for p. Yeah, solving for p is basically a direct result of picking the right test, entering in all the correct values into the test on the calculator, and then it should just spit out your p-value. Okay, so really number 2 is just going right with number 1 here, picking the right test. Okay, now that's going to be my hardest question just to answer in a short video, because picking the right test is kind of all of the last chapters that we did. You know, it's not an easy answer for me to give. My best answer would be, would be using this sheet here. And it's over here where it says confidence interval. It's the same thought process, just pretend it says hypothesis test. Okay, you first need to look at a problem, and you need to ask yourself whether it's an average problem or whether it's a proportion problem. If it is an average problem, then you're over on this side of the flowchart. And this first bubble here is if you have 1 sample, and this bubble here is if you have 2 samples. And I know all of these end with the word interval, just pretend they end with the word test. Okay, it's the same logic. So if you have 1 sample that they took in the problem, you're either going to be using a z-test or a t-test. And if you have 2 samples in the problem, you're either going to be using a 2-samp z-test or a 2-samp t-test. Okay? The only difference between a z and a t, whether you use a z-test or a t-test, or a 2-samp z or a 2-samp t, the only difference is based on where your standard deviation comes from. If the standard deviation comes from a little sample, then you're going to be using the t. If your standard deviation comes from a whole big population, then you will be using a z. That's the only difference between z-test and t-test. And we'll look at a couple problems. Now on this side of the flow chart, if it was a proportion problem, it's either 1 prop z-test or 2 prop z-test, depending on whether you have 1 sample or 2 samples. And proportions are always going to be problems that have z's in them. There's no such thing as a 1 prop t-test, okay? So proportions are problems, not averages, not anything like that. Proportions are when they say, I have this many people out of this many people, okay? And proportions, it's either 1 prop z-test, 2 prop z-test, that's it. So that's a little bit clearer, I think. This is where you have to, over here, really focus on where is that standard deviation coming from. So let me pull up your homework here. And again, I'm not sure which section I guess would be the best one to look at. Maybe 13 is going to be a NOVA. Well, let's look at this chapter 10, 13 stuff. This is the review. Okay, so this is a hypothesis testing question. Thinking of that flow chart, my first thought is this an average problem or is it a proportion problem? The fact that it says the word average tells me that in that flow chart, pull that back up here. In that flow chart, since it said average in the problem, we're over here. So we're either talking z-test or t-test, or the plural version of that, which would be 2-samp z-test and 2-samp t-test. Okay, so we know that we're really having to focus on, are we talking about a z-test or a t-test? And that distinction between the two of those is, where does the standard deviation come from? Does the standard deviation come from a tiny little sample, or does the standard deviation come from something bigger? Okay, so when you're reading these problems, you really need to focus on the sentence right here. Their standard deviation was $45. Okay, don't look at the whole problem. Focus on where that tiny little standard deviation comes from. Give me 1 second here. Okay. All right. So when you're looking at this, they say we took a sample of 55 shoppers that had this average of 128 and a standard deviation of 45. Okay, so that highlighted couple sentences there tells you where that standard deviation is coming from. It's not coming from all the shoppers in the world. This standard deviation is just coming from this little sample of 55 shoppers. And then there's another sample that there's another standard deviation. And again, this standard deviation of 30 is just being calculated from these 43 shoppers. It's coming from that sample, not from everybody in the world. Okay? Let me just reiterate the difference between Z and T. Z is when you have standard deviation from all. T is when your standard deviation only comes from some, when your standard deviation comes from a sample. Okay? So because the standard deviation is coming from a sample, this is a T problem, a T test. And the fact that we have this sample up here of 55 shoppers and then this sample of 43 shoppers means we have two samples, which means it's a two-samp T test. Okay? How's that logic for you? Okay, I'm going to be running out of time. I'm limited by how long these videos, how long I can make them. But hopefully that gives you an idea of kind of the mindset of how to approach these problems. This flow chart is kind of how I would recommend thinking about it. First decide, is it average or is it a proportion? And if it is an average problem, you have to decide between Z or T, and that's completely dependent on standard deviation, okay? So I think I've at least addressed all your questions. Although problem 2, I didn't really, it's just that solving for P is completely based on solving for the right, the hypothesis testing. I'm not sure what you mean here. In problem 1, where you said, okay, how do you get the difference between T and Z? Okay, we discussed that. P and M, I'm not sure what you're talking about there. So if you want to clear that up for me, I'll try to address that. But let me know if this helps and if you have any more questions, all right? Good luck, Mackenzie.